introduction. I'm Yoshihiro Nakayama. You can call me maybe Yoshi. That's how it goes there. So I'm talking about Antarctic. I wonder, have any of you have been there before? Oh, you have been there? Did you go with the?
Oh, it's a small ship cruise.
Oh, good. Very
A
good.
year ago.
5 years.
1 year ago.
Oh, 1 year ago. Was it related to the Dartmouth alumni?
No, this one wasn't. No.
Things? Oh, wow, good.
Yeah.
I'm very happy to see somebody who's been there before.
Yeah.
So today I'm talking, about Antarctic, but I mean, this is Antarctica. I've been there like 3 or 4 times now because I work on it for like over 10 years now. And one of the things that we are talking about today is that, as you know, maybe as some of you know, Antarctica is losing ice. Here we are seeing, this red part is indicating where Antarctica is losing ice, and the location where it turns slightly blue later on, that is the region where actually they're gaining ice. So there are hotspots in Antarctic. It's not, when you hear Antarctica is losing ice, maybe you think, oh, it's losing ice everywhere equally, but actually it's not the case. There are some hotspots, and we are actually seeing massive ice loss in one tiny region right here. So we'll talk more about it in the coming slides later on. But I thought it might be good to talk a little bit about myself. So I'm Japanese. I'm born in the south. I don't know. Have anyone you been to Japan? Good. I'm here from the south in Kagoshima, this is where I'm born. I grew up in the middle, and this is where I worked. But I thought it's kind of boring to talk a lot about this, so I'll talk about my hobby. So I'm a scuba diver, and I want to dive on the ice as well. So the region I go to is right here, up here. This is the northern part of Japan. Actually, in Japan, this is the southernmost location in the northern hemisphere. We have sea ice. Sea ice is the frozen seawater. So the ocean surface gets frozen somewhere up here off the coast of Siberia from Russia, where it's super cold. And then ocean current carries this ice and gets here. Now is the time when more or less a lot of sea ice is approaching towards Japan, and that makes Japan, especially northern part, extremely cold. So, this is the top view. What I'm seeing is something like this.
Wow. You go under the ice?
Yes.
Isn't that dangerous?
A little bit. I mean, the most important thing is that you should not panic. I mean, stay calm, whatever happens. I mean, there's a hole somewhere up there, right? So you just have to swim up over there, and then just get up. So for 5 years roughly, I had a job in Japan. And one of the reasons why I decided to go back is because I could go to Antarctic cruises. But another reason is actually I wanted to do this, right? I started scuba diving because I wanted to do this. Maybe can you make the room a little darker? Yeah. I think that might be better. So here I'm videotaping myself. So this is not me. I'm actually the one who's recording this. And I'm actually following this guy. We are going into the water from the coast, along the coast, right? And then now we are seeing, if you're interested, I can show you the real movie here because the zoom actually makes the resolution a little lower. But still, you are now seeing a little bit blurry things here, isn't it? Mm-hmm. This is because, when you think about making dressing for salad, right? You mix the soy sauce and oil, right? And then if you mix them, things get very blurry, right? That's the same thing. We are seeing the mixture of the fresh water at the top, which is the river discharge or melting of the ice. And then we are seeing salty water. So now you see things much better, right? This is because we are in the salty water layer. Again, after this, we are actually going up and then coming up to the sea ice layer. Again, I think we are seeing this here right now. But this is because this is the environment that I work on, the interaction that happens with ice and ocean. But at the same time, actually ocean, did you see the ice crystal that flows here? Ocean stratifies, and then there's a clear interface where we have, in this case, fresher water and salty water. And this stratification, that ocean stratifies, the water stratifies with the different water. This is actually very important things that we see here in the ocean. One thing that I noticed in this year, it was this kind of icicle kind of things. We call it vertical, and I have different movie for this here. I hope you see things. Do you see something coming out from here? I hope you do. And this is something called brine. So what happens is when you form sea ice, right? That's a frozen seawater. You create you make the ice much seawater much colder. You make ice, right? But the salt cannot really stay inside the ice, so they get injected out into the ocean. So what you are seeing here in this part is actually the injection of very salty water, which gets super cold inside the ice because the salinity goes super high, right? So the water temperature can go down very cold, like -10 degrees or something like super cold. And this cold water got injected out and forms this kind of icicle kind of things because it's just super cold and the surrounding water can freeze around it. Important thing is that actually this salt injection can actually make the water much saltier in some region of Antarctic. So sea ice formation and salt, this is called brine, that's the super salty water. This brine injection can create, it's something like you're putting the salt on in the water, right? So you actually make the density change. And that's actually one very important concept that I'm going to talk a little bit about today later on for Antarctic. I was super surprised to see this in Okhotsk Sea, that's the northern part of Japan. I did not expect to see this, and this was very interesting. Another thing I talked about, like stratification, right? The ocean stratifies. For Japanese, I don't really do this very often, even back in Japan, but many people take baths, right? They like to bathe in the bathtub in Japan, for Japanese people. But if you keep the water for 3 hours, 4 hours, if you jump into the water, you realize the deeper part is super cold. Have you had this kind of experience? I believe you do, right? Or even if you go swimming in the ocean, if you dive into the little bit like 2-3 meters below, you feel water temperature is much colder. This is one way to stratify the water. Even 2 meters or even 50 centimeters can stratify, you can keep the stratification. Meaning that actually ocean creates layers and then they have different water masses in different locations. And actually this is quite important. Here, I hope you see this. I see things much better here, but do you see like a little bit curtain-like features here? I hope you do. This is sometimes in the ocean where you have very good lid on top. In this case, I have a sea ice on top. And then there's a fresh water around it. That you sometimes see even layers, like you see a dressing, an interface between oil and water or soy sauce. We actually see very clear interface between the water, fresh water, and salty water. If you're interested, I can show you the movie later on because it actually looks much better on my computer. So this is the environment that I work on. It's a little crazy environment. It's super cold. It's difficult to get to. You need icebreaker to get there. And then ice, ocean interact, but at the same time, ocean stratifies. So it's a quite crazy environment. And we have to think about how ocean is melting the ice, promoting or triggering ice loss from Antarctic continents. So that's the topic that I'm working on. So I'm talking about Antarctic today. I believe you know that Antarctica is a continent, right? Do you know how big it is? It's gigantic. Yeah, I can see that. But do you think is it like twice as big as US or half of the size?
Oh, bigger than
US.
bigger than the US.
Good. That's right. It's about the Mexico and US combined.
Oh.
Exactly. Or 37 times of Japan. It's a continent and it's surrounded by the ocean. And that's actually one of the reasons why we actually see very cold things. That actually makes particular region that actually can get very cold in the Earth climate. Nowadays, we can actually see how Antarctic ice moves around. So this is a movie created using satellite data. Hope it stops. Satellite data, and as you see here, the snow falls on top of Antarctic continent. It slowly gets back towards the edge, of the continent, and it flows into the water. So they create like this kind of, rivers-like feature. We call it glaciers, and then it flows inside into the water. I believe some of you eat bread in the morning, right? And when you think about pouring lots of honey on top of it, then you create the tiny thin layers of honey, and this honey probably adverbs towards the edge of the bread. Ice behaves very much like honey. They have very similar fluid structure. So if you think of honey, then that's pretty much what's happening on the Antarctic continent. However, on Antarctic, we have bathymetry beneath it, right? Or some geometric structure beneath it. So maybe you can eat the bread and then you create some channels, right? And if you think about eating a bread and create channels, and then again, put a lot of honey on top of it, then the honey will advect inside, right? And it flows inside the channel. That's exactly what is happening, right? There are a lot of pre-existing bathymetric features. All of the ice, in this case, not the honey. I wish it's honey and it maybe tastes good, but these ice features, they advect following these bathymetric features, creating glaciers. That's the ice, river ice, right? And then these things goes into the water. What we are actually looking at, so maybe some of you don't really believe me that actually the ice flows. So here I have a movie. This is not from Antarctic. This is from Alaska. This is it's a time lapse starting from 2007 to 2009. But see, ice flows, right? It's a slow process, but it flows. And this is how in this case, this is a glaciers in Alaska, but something like similar happens, bringing ice flowing into the ocean. So let's take a look how it happens. So if you see from space, so here, remember when we look at this, this is actually a region where I said there's a hotspot, right, where Antarctica is losing ice. So let's take a look, focus on this glacier. There's one glacier here. There's one river-like features. So let's look into this region. Oh, this one right here. So here, I flip the picture, right? So here, this bottom part, this is Antarctic continent. This is the glacier, and this is the ocean. I hope you can pay attention to this monitor here and look at this cursor. Do you see that? Oh, first of all, do you see the ice advancing? I hope you do. As you see here, ice is advancing. This is indicating that glacier is flowing, right? Roughly 4 or 4.5 kilometers per year nowadays. So it's actually advances quite fast. And then you also witness some breakups of the ice. This is not sea ice. This is the ice snow, right? Snow created from snow. They compress, creates like solid ice, and then they are flowing towards the ocean. So this is the ice, the pure ice from snow. If you have a chance to eat them, this tastes much tastier than the sea ice. Sea ice still tastes a little salty. And then, so this is the icebergs. So you see some things breaking off. This is the icebergs. The Titanic, right? That's the thing that's icebergs, gigantic ice features. So I have been on icebreakers going to Antarctic. This is the movie is not coming out very well, but this is the German icebreaker called. I was on it, and if you see here, this is the iceberg. Do you see this is very thicker? This is roughly 30 meters, 20 meters, floating, meaning the entire thing could be 200 meters. If you see here, these are the sea ice. So see, this is more thin sea ice, and it's a frozen seawater. So I was participating on the Japanese research expedition to go to Antarctic, and this is the time lapse that we see from my cruise trip. This is a research cruise, so I was actually down there for like roughly 3 to 4 months. So you see a lot of things, right? There are many interesting things here, but first of all, it's pretty much covered by sea ice. This is sea ice, so it's frozen seawater covering here. And you probably realize that there's no waves, right? The waves are actually blocked by the sea ice. The sea ice dumps them. So only tiny, almost zero waves you observe here. So if you even have seasick, you actually have almost no problem. I hope you also see something big features over there. You see them? These are the icebergs. So if you look around, if you have been to Antarctica, I believe you have seen it, but you are able to witness like a lot of sea ice at the same time. If you are in the region, you can also see lots of icebergs. So this is the Antarctic. I'm giving you some little bit of the overview and of the summary of what I have talked about. So if you cut the ice, right? If you cut Antarctic into cross section, then this looks like this. The snow falls, creating a lot of ice. This ice flows towards the ocean. Actually, I didn't talk about it, but at some point, ice is lighter than seawater. So some regions, actually, the bottom geometry is located deep in the water. Ice starts to float and creating something like ice shelf-like features. And this ice shelf and ocean interact. We also have sea ice, as we talked about, it's a frozen seawater, and then icebergs, this is just the ice broken off, right? So this is kind of the quick summary of how Antarctica looks like. So let's talk about, why Antarctica is important, right? Because I've been studying this for a long time now. There's reason for that. And I'm giving you my perspective as a physical oceanographer. I also study a little bit like carbon and many things, but there are many reasons why Antarctica is important, but there are some important reasons in terms of looking from physical oceanography. So one of the reasons is sea level, right? I mean, as we talked about on the concept, So one question, how much, except for my students, right? My students, they're experts as well. How much sea level do you think is going to happen if you melt entire Antarctic ice? I give this question to many students, even if I give a talk to elementary school students or junior high, high school. I'm giving you a choice of 6 centimeter, 60 centimeters. Oh, you guys probably don't know the 6 centimeters.
That's all right.
You guys okay?
Yeah.
6 centimeter, something like that, right?
Yeah.
60 centimeter, 6 meter, and 6 meter and 60 meters.
60. 60.
60 meters?
60.
Oh, good, very good. So it's about 60 meters. So I have it here. It's about 50 to 60 meters. Do you know then what's the sea level rise that we are seeing right now? Per year.
A few millimeters per year.
Great. Yeah, that's right. Roughly 3 to 4 millimeters per year. So we have actually very much more ice in Antarctic. Only 1% change, even 1% change can make a huge difference in, for example, frequency of the high tide or flooding event or something like that. So that's one of the reasons why we care. So here, looking at it again, this is Antarctica, and we can see how Antarctica is losing ice, right? We have some hotspots. It's not that everywhere is losing ice equally, but this region called Amundsen Sea, now there's a Korean ships going down there, and actually I asked them to put some observation gear for me, so they are putting some sensors in the water. This region is attracting a lot of focus from the international community, and simply because this is a huge hotspot, contributing to, roughly contributing 80% of Antarctic ice loss is happening in this region. How do you think they are measuring this? This is measured by satellite.
Really?
It's very interesting. They have 2 pairs of satellite flying around. This is the mission called Grace, and there's a mission, another one called Grace, followed on the Grace mission. They are measuring the distance between these 2 satellites. right? These satellites are roughly 300 kilometers apart, but they're measuring their own distance, each distance, by the accuracy of your hair. So super accurate measurements. What you can do with this is because, I believe the gravity, right? Gravity is proportional to the distance squared. So if you have super huge heavy things ahead of the first satellite, the first satellite is pulled more than the second one because it's proportional to 1 over distance squared. So that's how they can actually monitor how much mass is changing on the Antarctica, as well as many different places. You can also monitor groundwater, many things on the Earth. So this is actually one of the things that actually revolutionized how Antarctica is losing ice, and we actually have measurements only from roughly year 2000.
So that's taking into account of the thickness. Then.
No. This is only looking at the mass, how heavy things are.
Yeah, but it's not just the aerial the aerial extent that's losing from the shelf. It's the actual volume.
Mass loss, actual mass loss. We are monitoring.
Yeah. Okay.
Actually, that's a very important point, and because this sensors monitors everything included. Yeah. So even there are things like mantle is changing. They also see mantle movement and many things.
I'm sorry, what movement?
Mantles, like you
I was going to ask that. Yeah, what's happening down the seabed too?
Right, beneath seabed, there's an Earth mantle is moving around as well. That has a longer time scale, so they are able to remove these signals, but that's one of the error sources, right? This thing is seeing everything, how mass is changing. That's why we also have different satellites monitoring the height, the thickness, how thickness changes. There are many ways to monitor these things, but this is one of the things. It's like a scale, if you're at home and if you have a scale, you can just jump on it and you see, how much you weigh. For Antarctic, you can't do that, right? So we need this. This is a scale. Not this one. This is a scale of Antarctic. Oh, so Antarctica is contributing roughly. I put the unit, say gigaton per year, 150 gigaton per year, and 1 gigaton per year is 1 kilometer cube of water. So roughly 150 of them, or it's actually about 0.3 millimeter per year of sea level rise that is happening per year due to Antarctic melting at this moment.
Yeah.
So this is Boston. I thought this might be an interesting example. Green is indicating the region where sea level is lower than 0.6 meter. This is 1.1 meter, and this is 1.7. So even 10%, even 1% of Antarctic changes can be important for some regions around Antarctic. My hometown is actually okay, but for this region, this is important. There's another important thing around Antarctic, and it's about the ocean. So we talked about sea ice, right? When sea ice melts away, there's a blind rejection. Cold water, cold air creates sea ice, and this sea ice is pushed away, and new ice is being formed here. Ice is pushed away, but what happens at the same time? You are injecting salt in the water, right? You've seen blind rejection in the movie in the beginning. That happens here. So actually, you're creating, adding salt on top of the ocean, creating ocean salt here, and that makes the ocean denser, right? You have a lot more salt. So what happens here is that, skip this one. So what happens is like strong wind creating high sea ice formation that creates dense water formation because it's denser. And actually this is dense enough. And this is actually coldest water in the world. It's the coldest and densest water mass in the world in the deep, like in the open water regions. So this is actually creating Antarctic bottom water. This water spreads. So if you see, this is the bottom part of the ocean. This color is indicating, how cold they are. So you can see from a southern ocean, from Antarctic continent, this blue thing is spreading all the way, pretty much everywhere in the entire ocean. So even if you go, Boston is not the right place, but if you go Pacific and if you put the bucket all the way deep, like 3,000 meter, 4,000 meter, If you get the water from there, then many part of it is coming from Antarctic.
Yeah.
And this is the way how you. So Antarctica is actually very important. Creating this water mass called Antarctic bottom water, which is actually having quite important impact on entire ocean circulation and then Earth's climate system. It's not just that, right? We talked about two contrasting things. One is ice shelf melting, so ice melting, right? If that is increasing, then of course surrounding ocean can get less saltier. But at the same time, we talked about sea ice formation or bottom water formation that requires ocean to be salt enough. So what is going to happen if both of these things are happening at the same time? If you see here, this is Antarctic, and I just say, okay, these are the important regions that previous scientists in the past, like 50 years, have looked at. These regions are the region where ice is melting. These blue are the region of the factory of lots of sea ice, meaning a lot of bottom water. Antarctic bottom water is actually formed in tiny specific region on Antarctic. These are the region where it's known to be the greatest source of Antarctic bottom water. So how are they going to interact? That is actually, and how are they going to interact? And at the same time, that means you're creating a lot of water, which is located at the surface of the ocean, bringing this water all the way to the deep within a few days, actually. So there's we also have some hypotheses that this might be also very important for carbon, ocean uptake the carbon, and maybe moving this carbon all the way to the deep water. So how are they going to interact? And how are they going to change in the future? This is a very important topic that attracts a lot of attention for scientists in the field. So, what is happening in Antarctic? Antarctic is losing ice, contributing to sea level rise, and formation of bottom water. Antarctic bottom water is very important. These are the two important things. So today I will talk a little bit about starting from what I started from very basic about Antarctic to what is really going on, and I'll talk a little bit about what kind of research I'm doing. So let's talk about Antarctic ice loss and why this is happening. So we see this slide already, right, many times. So this is Antarctic. We are seeing massive ice loss here, right here. So what is happening right there? I didn't talk really about what is happening for now, up to now. It's actually not ocean is directly melting and causing entire things. As you know, right? I mean, we talked about it. There's a river of ice. So these are actually very important things. There's a river of ice called glaciers, bringing this ice all the way to the deep water. The colors are indicating the speed of the ice flow. So this red part is actually roughly, this red part is roughly 4 to 5 kilometers or 4.5 kilometers. So actually the ice is bringing, this ice flow is bringing lots of ice and putting ice in the water. Right? We also talked about this. This is the ice. In the beginning, we didn't talk too much about it, but there's a glacier, right? Ice flow, river of ice, and then it starts to float. And this part is actually floating extension called ice shelf. That's the region where ice and ocean interact. They communicate there. And then there are a lot of ice being discharged to the water. So what is happening is, so actually this ice shelf is one of the key actions. The reason why this is the key is because, you see there are a lot of ice behind it. And this ice actually can slow down the ice flow, or in a way they can buttress the ice so the ice cannot really go all the way down to the water. There are a lot of French people in the community of Antarctic studies. When you look at this, for them, this is a wine bottle, right? And this is a Coke, wine bottle lying on the table, and this is the Coke, right? If you remove the Coke, I mean, if you think about, imagine you have a wine bottle, I hope it's not only important wine. If you remove the Coke, it will go, the liquid will go away, right? The same thing. This part is the Coke. If you weaken this Coke, then maybe this ice behind it can discharge into the water and contribute to sea level rise. This is actually exactly what's happening in the Southern Ocean or Antarctic. We are seeing acceleration of the ice. Ice glacier is accelerating, flowing much faster. compared to like 20, 30, 40 years ago. And that's the reason why we are seeing massive ice loss in Antarctic right now. So if you summarize this, actually the ocean is still the important things. There's actually pretty warm water in the ocean, which I'm not going to go talk about it today, but one of the big questions is why is this because of what we are seeing right now, is it happening because of the anthropogenic reason or natural variability? That's actually one of the big questions, because this warm water is coming all the way from deep water that cannot be interacted with the atmosphere. But this water is carried to this region, and this warm water is melting the ice. What is happening is we are seeing thinning of the ice shelf, weakening the cork. Cork gets weaker, speed up the ice flow, and sea level rise is happening right now due to Antarctic. There's a game created by British Antarctic Survey. I don't think you guys know British Antarctic Survey, but which we call it BAS, British Antarctic Survey, and that's one of the best institutes in the world for studying, one of the best, for Antarctic studies. And they created this game called icebreakers.com. If you are an iPhone user, there's app, so you highly recommend that. What we are doing here is there's precipitation, snowfall. I have a control bar, so I can change them. On the other side, I have the ocean temperature. This is the control bar, I can change it. So what I did is I moved this color, the red dot down, so meaning that the ocean is now colder. And we are seeing growing of the ice. So if I do this, to the back and forth, you see the ice has grown, right? Ice has grown on this side, right? What I'm going to do next is I'm going to increase the ocean temperature. What I want you to observe is actually the ice is retreating back. And yeah, see, I'm going to increase the ocean temperature, and actually that will speed up the ice flow. So now the ice is speeding up, and then there's a retreat of the ice. And then look here, very rapid ice loss. Did you see? I'll do it again. See, the ice loss is happening, and then massive ice loss happens.
Yeah.
This is happening because ice is accelerating and transition to different state. So ice is initially much slower. With the deepening, ice is going. Oops. This is a game to feed the penguins. So if you are doing the game, you have to feed the penguins to make them happier. So why it's actually important is that the main message is the trigger is the ocean. The warm ocean water has to be there. At the same time, I don't really go in detail today, but the bed deepening here, geometry deepening here, they can't stop. As soon as it's getting shallower, they can stop. So the reason why it stays there, stabilizing here from here all the way here, is because the ocean bottom is getting deeper towards inland. So that's the two important things. That's the two conditions. So what about the Antarctic continent right now? We are seeing massive ice loss in one region called Amundsen Sea right now, right? But actually, there are other regions that meet the conditions that the ocean temperature is warm enough. Here, Amundsen Sea, this is actually quite warm, 1 to 1.5 degrees C. This region called East Antarctic Totten Glacier, this is actually one of the regions where Australians or Japanese, we are paying a lot of attention. Ships are going there simply because we have stations nearby. So, countries are kind of divided by the location where they can go to, because they have to go and supply the station, right? But this is the region, it's also meeting the condition. This is the region called Weddell Sea. This is the location where German are always going there. And we also see -1 degree C, which is actually a little bit warmer. -2 is roughly the freezing point for the seawater in the ocean water because of the salt. So all of these regions kind of meets the first condition. The ocean is kind of warm enough. Now I'm going to overlay a bathymetry on top. Here, this color is indicating the location where it's shallower than 0. Meaning actually there are a lot of locations where it's below sea level, and even getting deeper inland. For example, this region Amundsen Sea, right? That's the region where we are seeing massive ice loss right now, right? This is the region where we are seeing massive ice loss right now. It's going deeper or more blue inland, meaning getting deeper inland. So this is actually the region where we are seeing massive ice loss, and we may be seeing, even from now on, we might be seeing further acceleration of how much ice being lost from this region. Another region that we are looking at, this Totten Glacier region, that's also the region where we are seeing bed getting deeper inland, and this region also getting deeper, some regions around inland. So indicating that, nowadays we only see one region that we are seeing massive ice loss. This can further accelerate. At the same time, other regions can start accelerating at the same time. And we may be starting to see some signs of acceleration right now in the recent years. The difficult thing is that we have little understanding of the ocean because of the data. For example, one of the regions that we are talking about today, this region, the earliest observation was in 1994. So we only have like 30 years of time series. Ice-wise, we have data only from 2002 in terms of the scale. If you think about satellite, then we may be able to go back like 1970s by satellite pictures, but that's about it. So what is really going on and how Antarctica in total can contribute to sea level rise is a huge uncertainty. And that's the reason why we really need to understand what's going on and what may happen in the future. So in my group, and let's talk about exciting things for the last roughly 10 minutes, I believe. So in my group, to understand what's going on, how can we better understand what's going on in Southern Ocean and Antarctic? In my group, we are combining observations and modeling, better understand what's happening, understand processes, try to identify physics that controls, for example, how the water gets to the ice and melt the ice, for example. So we are really trying to nail down the physics so that we can better predict what will happen in the future, not just using the numerical simulation and say, hey, this is what happens, not really knowing what's really happening, because it's a very complicated system. Ocean is super complicated, and we need to understand what's happening in the data, but we can't really do that just with the data, because data only tells us that specific locations where we can have observations. So we combine data, we develop the model, improve the model so that we kind of see what's going on in the data in the model. And then we explain what's the physics behind this, controlling such things. This is the main theme of my work. So, when you do ocean observations, this is like this. This is taken from from the cruises I was participating in Germany. And here we are deploying this huge things called CTD into the water. We have salinity sensors and temperature sensor. Sometimes we have oxygen. We have we also measure light, and then we actually measure the turbidity in the ocean that sometimes corresponding to how much photoplanktons we have. So this is what happens. We deploy the sensors down. The sensor has to go all the way deep, right? There's no satellite that can measure temperature in the water like 500 meter depth. We have to move this sensor down all the way and take the measurements. It's like roughly 1 meter, 1 meter per second. So if the ocean is roughly 4,000 meters, it takes us roughly 1 hour and a half to get down the sensor down to the bottom, and then 1 hour again, another 1.5 to recover them. And along the way, actually, for the return trip, they close the bottle by firing some switch nowadays. And then we can sample the water, and we can also use the water to measure oxygen, salinity, or many different dissolved material that can actually tell us a lot about how ocean circulates. I was on Japanese icebreaker, and actually I was doing these crazy things, throwing things from the helicopter. And because we are not able to bring icebreakers to the region surrounded so much by the ice. But if we can do such things, we can actually grasp the big picture of how ocean structure looks like in the region, and allowing us to target or identify target region that we have to move the ship there. And that's actually much, much more efficient than trying to go everywhere by ship, because that's pretty much possible to do it. Here we drop the sensors, this sensor sends the signal and we retrieve through the antenna, and we can actually get a good image of how the ocean looks like. For example, this is the region called Totten. We talked a little bit about Totten. That's the eastern, this side of the Antarctic. We dropped roughly 60 sensors only within 6 or 4. I mean, with one trip, we can actually drop roughly 10 sensors. So we actually get 10 measurements. And in this location, I'm not going to talk so much about it, but actually we did not know. We almost have no measurements in these regions because so much ice is in there, even in summertime. However, if you're flying with helicopter, you can actually try to hit a small spot. Even the size of a helicopter, we can actually drop the sensors down. So we are actually able to find actually very, very wide pathway of warm water going towards the ice. This actually turns out to be one of the big discovery at the time, because we only saw tiny little warm water at this location. Everywhere is kind of imagining there's not much big pathway of warm water towards this region. But we kind of discovered, oh, there's a big pathway of warm water. My student Shuntaro, he's actually working on this topic right now, trying to understand what is the physical processes driving warm water intrusion, as well as keeping this very cold water here that protects the ice right now. However, when there's a huge heaving of the water, then that can be a potentially huge impact on ice around this region in the eastern part, this location, the Antarctic. So this actually indicates the big discovery as well as potential vulnerability of how this region could be to the shadowing of the water mass right there. In my group, as I said, we combine observations and modeling. So we develop ocean simulations. This is the example of ocean simulations for this region right here. This is the mountain sea. This is the region I said is contributing a lot to the melt. Here I'm showing you 500-meter potential temperature. So it's basically temperature in the 500-meter depth in quite deep location where actually there's a pretty warm water. Warm, as I said, by 2 degrees, right? But still 2 degrees is pretty warm. Probably ice feels like jacuzzi, right? For them. So you see here, this is the open water, meaning that deep look. If you know a little bit about the ocean, there's a continental shelf, like 300 meters, right? And then it gets deeper, and then there's deep water. So this part is deep water, roughly 3,000, 4,000 meters, and there's a warm water is located already there. And this warm water is carried by ocean circulation. Ocean current is bringing water towards this area. This is the Antarctic continent. To the Antarctic continent, beneath the ice shelf, ocean water communicate with the ice, and some region contributes so much to the melt and melting the ice that weakens the ice shelf, the cork, and then the ice is now discharged into the water.
So besides the warmth of it, what's the salinity?
Salinity is yeah, that's the important thing that sets the density.
Yeah.
What's the salinity level? Like
what's the salinity?
roughly 30 something. That's the question.
Yeah, how does the
Salinity being determined?
No, you have to take samples. No, how does the salinity affect the mixing?
So of course the salty water tends to be denser, right? So it's located in the deep water.
Yeah.
At the same time, you could have colder water that is also denser. So the density is determined by temperature and salinity, as you imagine.
But if it's warm and salty.
So actually, if you see in the water, sometimes you find warm and salty water, and you may have seen, the figure I showed you. So sometimes, in particularly around the Antarctic, you find cold and fresh water on the top. Beneath, you have warm and salty water. So how this water circulates and carried towards the ice is a very important thing. However, this warm and salty water, this is actually formed in the Greenland. So it's the northern hemisphere. There's one region where water gets super salty, super cold. This water goes down to deep water. This travels roughly 2,000 years, all the way to Southern Ocean. And then because of strong wind and some water mass structure allows this water to get shallower. And this is the water that is contributing to melt. So there's no way you can warm this water up. Human contribution is not warming this water up. So why we are seeing massive ice loss right now in this location is one of the biggest topic in the field. And actually, I wrote just submitted a proposal trying to understand the human impact on this. And is it really caused by humans? And if so, then I mean, it is likely that the wind is changing, and wind is changing, ocean circulation is changing, and now this warm water can reach there. That's the hypothesis, but it's difficult to prove. You know, it's not that we are seeing wind is fluctuating so much. So it's very difficult to see some significant changes in the wind. This is another simulation. We can see, you know, very lot of different structures, like lots of eddies, lots of small scale circulations. And here, this is the location I said ice shelf. So warm water is traveling towards the ice shelf and contributes to the melting. So we are doing lots of different kinds of simulations, and that's what is happening. So in Dartmouth, that is great. One of the good things about Dartmouth is me as an oceanographer, I'm working in theater school. We also have a lot of specialists working on the ice. So we actually have a lot of components on specialists in each component. We actually work together to better predict, and hopefully we can better predict what is going to happen in Antarctica. And that's our aim, to do that hopefully within 5 to 10 years. What I found very interesting about Dartmouth is I realized after I moved here, because I actually got here roughly 1 year ago, and I realized that Dartmouth has a very good extensive record of polar archives. So I'm not going to go so much in detail, but actually I found one book talking about Ross Sea, which is one region right here. And there's a ship called Discovery. This was one of the ships that brought Amundsen to Antarctica in 1902. And this ship was actually in the Ross Sea, in one of the key regions in 1936. So, as I said, one of the biggest hurdle for us is to understand what's going on in the past. And we have limited understanding of the data or observations in the past. However, I realized that there might be a little more data that has not been discovered in the community yet. And maybe those things might tell us a little bit more about, you know, this is like a time machine, right? You might get a good data at a location that didn't think that there's a data. So such thing might be also, able to tell us what has been going on. For example, we identified quite a lot of data from 1936 and 1929 in the region, which is right here. And that might tell us a little more about, these could be very, very important things, because, you know, one data point, still ocean does not change in a short time scale. It takes a long time to change. Ice is even slower time scale change. So what could be happening? One data point at that time can tell us could tell us a lot about what's going on in the Southern Ocean and Antarctica. So stay tuned. I hope we can talk more about it in the next time I talk to you guys, or maybe on my website. So to summarize, what's happening in Antarctic? Antarctica is losing ice, contributing to sea level rise. Another important thing is formation of Antarctic bottom water. This is a very important region, both from ice-ocean interactive features. At the same time, it's ocean circulation. In my group, I believe very important thing. The important thing is to understand the physics. Not understanding physics, just doing simulation does not really give us much confidence. But if we can identify physics driving ongoing changes, then we with a little more confidence understand what is going on at the time, and maybe we can better predict what could happen in the future. So in our group, we are trying to understand synthesized observations and model and investigate historical record, aiming to understand the physics driving ongoing changes and better predict what could happen in the future. Thank you very much. Questions?
Yeah.
Yep.
Are you working with the people that are with the Korean group that's down?
Yes. Koreans, did you say?
The Koreans doing the space drilling. So are you getting data from them? Are you collaborating with that? With
Yeah, I don't know how you did you read that on the newspaper?
Yeah, the New York Times has the daily updates.
Yeah,
The guys. It's fascinating.
Yes, I send the sensors with them. So I asked for
Oh.
collaborators, and my sensors, I hope, is being deployed. But yes,
Yeah.
I mean, this is very much international effort. And on Korean ship, I have my colleague who I wrote proposals with is now on the ship as well.
Yeah.
And I mean, it's a really a big teams, including UK, Sweden, I believe, Korea, China. I don't know if Japanese people on board, but it's a very international effort.
So
yes.
what sensors are yours?
I'm measuring temperature, ocean
Okay.
temperature. But in the ocean, there's many ways to measure ocean temperature. And what we are interested or what we want to get is a time series. So we deploy a sensor called moorings. We have a big bait, and then we have a buoys.
Oh, okay.
We have a float, and then we drop them in the water. We keep them for 1 or 2 years, and then hopefully we can recover them, and then we get the data. Yeah.
I was wondering, it was fascinating about the physics that's involved. Are there models and data banks on what's happening biologically too?
Yes, that's another level of difficulties, but yes. For example, biology, we can actually see it from the space.
Oh,
The ocean colors, right? The colors changes with the amount of planktons in the water. So it's also difficult to see, right? I mean, from the space, you only see ocean top only, not in the interior. However, we do see every year in Antarctic, we see a massive photoplankton blooms, meaning that the huge amount of biology that grows when ice retreats, right? Antarctic is crazy. Sea ice covers the ocean. At the same time, there's no sunlight in winter.
yeah.
So a lot of biology, nutrients accumulates in the water. As soon as you have a sunlight, a lot of photoplankton starts to bloom, gets much larger, and then zooplankton eat them. Whales, many things, they eat them. So there's every year, there's a huge, massive photoplankton bloom that is happening. And that also contributes to carbon uptake by the ocean as well. Here, this is a particular region, we have the pipe connected from the bottom of the formation that carries this water all the way down the deep water, potentially capturing some carbon in the deep water. At the same time, a lot of photoplanktons, they use the carbon in the water, they create their own bonds with the carbon, they die and they sink, and they also put the carbon in the water. So as you said, that's exactly right. And we have a lot of data as well, but it's super, every year it happens, it's super fast. So this is way more difficult, but I have a project working on that, and this is a very interesting topic as well.
Thank you.
Any other questions?
What is the Dartmouth Polar Archive that you mentioned?
Oh, this is a book.
A book?
So yeah,
One book?
no books, many books. So that was actually I don't know the exact reasons, but I think there's one foreign professor at the time, and they collected a lot of books. I think so. The Dartmouth long history of Dartmouth allowed them to collect a lot of books at the time, and at that time, people went there, published the data in this kind of format. Right, these are all the data.
Wow.
So Dartmouth has a lot of polar archives, meaning lots of books from 1930s, 1920s
Where are they?
in the library.
Baker?
I don't know where. It's in my collaborator's office right now,
I
so we
see.
can't find them anymore.
Around,
Yeah.
would it be in Feldberg Library?
Probably around right now.
Don't know which library. Right now it's in the engineering building library.
Okay.
Yeah.
Okay.
But that could be because of my collaborator library would have taken it and it will be there. So I'm not sure where it was originally stored. However, if you go to some of the old books library, there are also different collections. Like there's a diary from the staff who was in the polar expeditions, and this guy was getting crazy, and they still write their diary. And in the end, I don't know what happened. I forgot what happened to this guy. I'm more interested in the data, but they are crazy diaries. And then I think they're playing soccer, and then one of them get missing, and that kind of crazy stuff. So it's a lot about report at that time.
Is anybody looking at the strength of the ice in the glacier and doing any predictions on when there's actually going to be fracturing up into the glacier?
Yeah, yes, yes, there is. My colleagues are more working on ice itself.
Yeah.
And I believe what you're talking about is how ice can collapse because of material reasons, like
Right.
the strength of the ice.
Yeah.
That's a very important topic, and how ice shelf can sustain and when it collapses. There are some people who propose that there might be some ice collapsing mechanisms that could potentially become important. But this is still one of the debates. So yes, the colleagues.
And how it's anchored on the ground
That's what I was
to
gonna
that
ask.
whole interface there. That's right. The ice strength could collapse.
Yeah.
So
That's
that's a really important. That's right. Get a handle.
That's one of the things I was wondering about, whether, when you take all the ice away from Antarctica, what is the land mass like underneath all of that? Do we have any idea?
Land mass meaning what kind of soil we find. That's what you mean? Or,
Yeah, or rock, or whatever is down
I
there.
mean, it's a
Magma.
rock. I mean, some regions it should be rock.
Do we have an idea of the profile of a?
I'm not the specialist for that, but I have been to Antarctica, and for some regions, if you for example, if you go somewhere in the suburbs, right, like the outer edge of this, you actually see the ground.
Ah.
So some stations are actually even built on the rock features.
Got it.
Also, if you go Antarctic, you see some mountains that is, getting up
Coming
from the
up.
ice as well. So there are a lot of rock kind of features that you find there.
Wow.
You should go one day.
All these questions.
I mean, I recommend going to Greenland as well. I mean, Greenland and Antarctica might look a little similar, but it's way closer from here to Greenland. It's way closer. Probably going to Antarctica can take up to 1 week, maybe, if you get on the ship. But if you go to Greenland, I think you can. There's a flight I heard there's a flight starting from New York to Greenland, maybe this or next year. So maybe one direct flight.
That happens to be very different.
I believe it is almost time, but maybe one last question if there's any.
Thank you.
Thank you.
Thank you.
You're-